Hi guys, today's notes are on 4.4a, the remainder and factor theorem. So up until now, everything in chapter 4 has been sort of this review and preparation. So we've done multiplying polynomials, factoring polynomials. All of this is sort of like just getting you ready for this, like how it all comes together. And so now chapter 4 is going to really begin. I'm going to take everything that we learned, or a lot of things that we learned, and put it all together so that we can, here's our goal, sketch an accurate graph of a polynomial. Okay. So today let's start with the remainder theorem. This is a theorem that states when you divide f of x by x minus k, and this means it's possible to synthetic divide because it has x minus k with no squared, right? So it's just x and a number. When you divide it, the remainder is always the same as if you take this number and plug it in. Okay, plug in the 0. You can think of it as an x-intercept, but it's not an x-intercept if it has a remainder. Okay, so if you take this 0 of k, after you switch the sign, you're going to plug in that 0. Okay, so it's not the number 0. Sorry, this is going to be a little confusing. It's not the number 0. It's this number that we switch the sign here. Okay, so let's do a quick review. We'll start with synthetic division. Okay, so it says when you divide, our remainder is going to equal when we plug this in. So our answers here will be the same. So for synthetic division, we're going to start with x cubed, x squared, x's and numbers. I always write these in so that I don't miss any zeros. So I have 5, -1, 13, and 29 to match the coefficients here. I need to leave enough space underneath, so please make sure you do so. And x minus 4, if I set it equal to 0, solves for x equals 4. Okay, and that number goes out here. Okay, so at this point, the process of synthetic division is that you drop your first number, or coefficient, which is 5, and you take 5 times 4, right? Multiply your numbers outside, which gives you 20, and then you add -1. Okay, so add up and down, that'll be 19 times 4, oops. Okay, so that'll be 76, and then plus 13, which is 89, and then 89 times 4, which is 356, and then you plus 29, okay, which is 385. That's my remainder. Okay, so for this problem where it says find the remainder, that's my remainder. Okay, I'm just going to take a moment to remind us how to write the quotient or the answer of a division problem. So please remember that your leading coefficient stays the same, but your exponent or degree drops by 1. So we'll have x squared plus 19x plus 89, and then our remainder is 385 over x minus 4, which is what we were dividing by. Okay. Now let's do the other side. Okay, we're going to take f of 4, so we're going to take 4 and plug it in for x. So we'll have f of 4 equals 5 times 4 to the 3rd power. And everywhere I see an x, I'm going to replace it with parentheses 4. Okay. So at this point, I want you to make sure that you're only using addition, subtraction, multiplication, or division functions on your calculator, because I want to know if you know how 5 times 4 to the 3rd power works. Right, so this is really saying 5 times 4, 4, and 4, 3 fours. And then there's a negative, and then 2 4s, because that's what it says. And then 13 times 4, that's going to be 52, and then plus 29. Okay, so I don't know 20 times 4 times 4, but I do know 5 times 4 is 20, and 4 times 4 is 16. This is going to be negative 16. Okay. 20 times 16 is actually simpler than it looks. If you take away the 0 and you do 2 times 16, that's 32. And then you add the 0 back in. Okay. Then I'll have minus 16 plus 52 plus 29. And if you add those in your calculator, you get 385 equals f of 4. Just to show what we plugged in. You guys see how like these two things are the same? And this is not a coincidence. This actually works for anything. If you change this to a 3 and this to a 3, right? It'll still be the same exact remainder and evaluated value. Okay. So the factor theorem then, let's move on to our next one, states that if x minus k, which is sort of like our term here that we're dividing by, is a factor of f of x, then k must be an x-intercept. Okay, and how do we know this? Because f of k is just y, and if y equals a 0, that happens to be an x-intercept. Right? Remember like back when we were looking at tables, and anywhere there was a 0 for y, we knew that x was an intercept. And so that means if we have a remainder of, if this equals to 0 right here, right, when I plug in a number and I get 0, that must mean, according to our remainder theorem, that these two are the same, so that the remainder is 0. So what the factor theorem states, okay, in simplified version, is that x minus k is a factor of a polynomial when the remainder is 0. Okay. So what we're going to do, or I could say or f of x equals 0. Okay. So what we're going to do now is just use both methods. Eventually you're just going to pick one, and I would suggest synthetic division. But for right now, let's use substitution first and then synthetic division. There's a reason I'm not doing synthetic division first. Okay. So let's plug in negative 5 in for all of my x's. So we have f of negative 5 equals 3 parentheses negative 5 to the 4th power plus 15 times negative 5 to the 3rd minus negative 5 squared plus 25. Okay, so, oops, not negative 3. This will be positive 3 times negative 5, negative 5, negative 5, and then 15 times negative 5, negative 5. Oh, there should be 4 here, sorry. Then I'll have a negative, negative 5 times negative 5, and then plus 25. Okay, so this gets a little bit messier because there's so many 5s to worry about. Well, the first thing I'm going to do is right here, negative times a negative is a positive times a negative, which is negative 25. And you guys see how these two happen to cross out. Okay, this doesn't always happen, but this is just like if it does, this is what you can do. 15 times negative 5 is negative 75, and 5 times 5 is 25. The negatives cancel out. Here, 5 times 5 is 25. Negative times negative is a positive. And the really cool thing right here is if I have 3/4, that's 75 times 25, and just bring that down, right? So I don't know 75 times 25, but I do know that a positive 75 times 25 and a negative 75 times 25 cancel out. And so f of negative 5 is equal to 0. Okay. Oh, I shouldn't box that. That's not my answer. Sorry. And why is it not a 0, the answer? Because the question asks, determine whether x plus 5 is a factor, right? So if you want to determine is it a factor, you have to answer that question. Yes, x plus 5 is a factor of f of x because f of negative 5 equals to 0. Sorry, I ran out of space. That's this one. Okay. Now let's use synthetic division and see what happens. When I did this in class, a lot of students made a small mistake and they forgot to add a 0 in. So this is why I always do this. 4, 3, 2, 1, and then numbers for synthetic division. So that gives me 3, 15, negative 1, here's my 0, and then 25. Okay, so this one a lot of students forgot in class. Since I have x plus 5, we switch our signs to x equals negative 5. And so I'm going to bring down the 3, multiply outside, add inside. This one I always get tricked up on. Negative 5 times 0 is 0. And 5 times negative 1 is positive 5. We're adding. And 5 times negative 5 is negative 25. And we get a remainder of 0. Okay. So we can write the same thing. Yes, x plus 5 is a factor of f of x because the remainder is 0. Why don't you try now? And what you would do is do both of these and see if your answer comes out the same, right? So check to see what you get when you plug in. Now just be careful. It's going to be f of 4 and synthetic division using a 4 on the outside, not a negative 4. Okay? Because you have to remember to switch your signs. See if you can get the same answer. Okay? I'm going to move on to the back. There are a few more examples there. I'm going to take what we learned and keep going. Example 2 says, show that x plus 2 is a factor of f of x, and then factor completely. So our goal actually is to factor completely. Now, the question is, why can't we just factor by grouping the way that we've been learning so far? Let's take a look. So if I tried to factor by grouping, these are the two that go together, and these two, I can take the GCF of x squared, and then this one has only negative 1 in common. If I write this out, I have x squared on the outside, and I have x minus 2 left, and then negative 1 on the outside, and then I have 13x plus 10. Do you see how these two parentheses are not equal to each other? So you cannot factor by grouping. Because these don't match. If we can't factor by grouping, then you must use synthetic division, but you also must be given a factor. So now, let's use synthetic division with the given factor. Okay? So we are going to write in, let's see, x cubed, x squared, x's and numbers, just to be safe. The positive 2 becomes an x equals negative 2. I'm going to circle it so I don't lose my negative. And then I have 1, negative 2, negative 13, and negative 10. So I'll bring down my 1, multiply outside, that'll be negative 2, add inside, negative 4. Multiply outside, positive 8, add inside, negative 5. Multiply outside, positive 10, that has a 0 remainder. Sorry, this looks like negative 70, but this is negative 10. Since there's a remainder of 0, that means that x plus 2 is a factor. Now, how does that actually help us? Well, if I wanted to write this as x plus 2, okay, If it's a factor, that means now I have my remaining term here, 1x squared minus 4x minus 5. And this is now factored compared to what I was given originally, even though I didn't use one of our original factoring methods. Synthetic division also works. Now if I covered up this part and I gave you this red problem, you guys could technically find two numbers that multiply to -5 and add to -4, which would be -5 and +1. So the blue part stays the same. We are given that factor, so we must keep it. But the term that we found after synthetic division can be simplified or factored more. So that can be x minus 5 and x plus 1. Okay. Why is this helpful? Well, if we keep going in the next problem, now I know what my x-intercepts are. Right? And our x-intercepts are -2, +5, and -1. And I can graph it, and I can use my end behavior, leading coefficient, to sketch a graph. So let's see what that all looks like together. Okay. They're giving you a different factor this time. So now I'm giving you x plus 1 as a factor. So we're going to do synthetic division using x plus 1. Okay, why don't you try this yourself? Okay. I won't talk, I'll just write mine. You do yours. Please make sure you switch your signs though on the outside. I get a remainder of 0, which means it's a factor and I can keep going. So what's left? Oops. So after I synthetic divide, my answer, or the quotient, goes in its own parentheses, and the given factor goes in its own parentheses, which means I already know one of the x-intercepts is going to be -1. Okay, the question is, what are my other two x-intercepts? So now I'm going to do my x method, what multiplies to -10 and adds to -3. That'll be x minus 5, x plus 2, and then here will be x plus 1, bringing it down. So now that I'm completely factored, I know my x-intercepts are going to be also 5 and -2. So now let's sketch this, and we'll put our x-intercepts at -1 on the graph, 5 on the graph, and -2 on the graph. Okay? I didn't give you like very clear lines because it doesn't need to be to scale. So it just has to be ish in the right place. Remember from chapter 2 that our y-intercept is always a term with no x's. Okay? So -10. That means down here will be my y-intercept. Now, I can sort of see how the graph is going to go, but we don't know like how to connect these points unless we think about the leading coefficient and the degree. The leading coefficient here is positive, so I know that the graph is going to go up on the right. And then I know the degree is 3, because that's my biggest exponent, or largest exponent of, and these are for f of x. Okay, not these newly simplified versions, but just for the original. So I know there's going to be 3 terms. Okay, so here's where you sort of have to just like eyeball it. For me, like I'm coming down this way, but you can also just connect the 5 and -10. This just happens to be the way that my graph turns. Here's my one direction, second direction, and third direction. You have no idea how low this graph turns or how high it turns, right? So all you can do is a sketch, which means it's not necessarily accurate. And that's putting it all together. So now let's do one last example. What if I don't give you a factor to do synthetic division with, but I give you a graph instead? Well, synthetic division out here, these numbers are factors or x-intercepts, right? So I can identify my x-intercepts at 1 and 3. I don't know this one. Okay, so I can use only the x-intercepts I see that are whole numbers for synthetic. So step 1, you're going to do synthetic division with one x-intercept. And then you're going to use your quotient or answer from there and synthetic divide with the second one. And that will give you the third x-intercept. Okay. So let's do it. 3, 2, 1. I'm checking exponents right now, so I don't need to worry about them. So there's no zeros. Let's use and go in order x equals 1. That's an x-intercept. Okay. So I will go bring down the 3, multiply, add, multiply, add, multiply, get a 0. Okay. So what does this mean? This means that I have x minus 1 as a factor, because factors and x-intercepts are inverse signs. Okay, one positive, one negative. And then now I have 3x squared minus 14x, plus 15. If you wanted to now, since we know there's going to be x-intercepts, you can factor this using your a times c double GCF method if you wanted to. Okay. But I think most of you guys are so comfortable with synthetic division that you can also take this and use it in a second synthetic division problem. So I'm just going to switch my colors here. So I'm going to use 3, negative 14, and 15. And then my second x-intercept that I have to use, I'm not using 1 again because I used it, is x equals 3. Okay, so now I can bring down my 3 and run through the whole process one more time. So now I have x minus 1 from the first one. I have x minus 3 from my second x-intercept. And my third factor is 3x minus 5. Because it was x squared here, but now it's becoming an x. Okay. The directions, I'm sorry I didn't read them out, was to factor the polynomial completely, which I have done, and we are done. If I had to find this x-intercept, I could do set it equal to 0, so it would be 5 over 3, which is right there in the middle. Okay. Sorry, this is a bit of a longer video. So the last thing we're going to do is one quick word problem. We won't solve this word problem necessarily, but we will set it up to understand what it's asking. During the first 5 seconds of a roller coaster ride, the function h of t represents the height in feet of the roller coaster after t seconds. You have the graph of the function shown below. How long is the roller coaster at or below ground level? Well, if this is your ground, then we are looking for this, right? And we need to find from 2 to here, how long is that time? Okay. Well, I know this is 2. And I need to find this x-intercept. I also know this is negative 1. So could you guys use synthetic division 2 times to find the x-intercept of this third factor? Okay. So what you can do, we're looking for the x-intercept, and to do that you're going to subtract your third x-intercept on the graph. That means you have to find it. Okay, so use synthetic division 2 times, I shouldn't put an x because that looks confusing. We'll write it out. 2 times, okay, to find it, minus the second x-intercept to find how long the roller coaster is below ground. Okay, that concludes our video. You guys have homework to practice, and we will continue tomorrow.